Hello, my dear students. Welcome back to the chapter that is Organisms and Population. And students, in the last class, we discussed one of the important concept that is about the population. Okay, population attributes and everything we completed: the birth rate, death rate, sex ratio, and then age pyramid. Then, along with that, the population size and the population density. Okay, these all things we completed, and along with that we started with population growth, and we studied the factors affecting or factors influencing the population growth, that is natality, mortality, immigration, emigration. Okay, natality is nothing but it's a birth rate, and mortality is nothing but it's a death rate, and immigration, it is a number of individuals, okay, those enter to a population, okay, of the same species. Okay, that is immigration, that is indicated by I. And emigration, it is the number of individuals of the population who left the habitat. Okay, they are left the particular population. Okay, this is the population growth, and these are the four basic processes that that fluctuate the population density: natality, mortality, immigration, emigration. And students, natality, mortality, immigration, emigration definitions important for your exam, so please remember that. Okay, and here they given the formula, that is population growth. Here the population density, okay, at a given time is written as a t plus 1. Okay, and the formula n plus, here n t plus 1 is equal to nt plus b plus I, birth rate, plus immigration, and then minus d plus e, death rate, and then emigration. Okay, this will give the population density. Okay, the population density increases if b plus I is more than d plus e. Okay, obviously the population density is going to be increased if the b plus I should be more. If it is 100 and d plus e is 50, it means b plus I is more, so the population density automatically increases. Okay, that they mainly given here. And here in this you can see here in this chart, immigration, and here natality, mortality, and then emigration. Okay, immigration mainly increase, or there's an increase in the population density because other species entering into the population. And natality, it's a birth rate, obviously there is an increase in the population density. And mortality is death rate, so it is indicated in minus because mortality can decrease the population density, and then emigration also decrease the population density, so it is denoted as minus. Okay, this is the thing about the population growth. And now students, will move to population growth. Okay, population growth we will discuss here. It is also a very important one, please remember this population growth. And here students, here the population growth, under normal conditions, usually under normal conditions, births and deaths are important factors influencing population density. Birth and death rates are influencing population density, and in normal cases. And in immigration and emigration have important only under special conditions. Under special conditions they are going to be affect the population, because immigration and emigration will not happen continuously, but birth and death, it is natural and it can happen continuously, so those will affect under normal conditions. But here immigration and emigration, under special conditions, they are going to affect the population growth. Okay, that is the thing. And students, when we come to discuss about the population growth, there are mainly two types of growth we can see. One is exponential growth, another one is logistic growth. Both are very important. We will discuss each and every. Okay. And students think the population or the growth of a population with time, they show specific or predictable pattern. Okay, because the growth of a population with time, we can take a graph. Okay, we can calculate that. Okay, according to time there is a changes or variations in the population that will calculate. And okay, the population growth is going to be affected, or it is depends on the resources, and then along with that it is depends on the food availability, and along with that the habitat. Okay, usually population growth is going to be affect, that can happen in case of population growth. So the resources and the habitat is very important for a population. Usually two types of growth we can observe in a population. One is exponential growth, another one is logistic growth. Okay, first we will discuss about the exponential growth. And students, here in exponential growth, what will happen? Here the resources, that is food and space, or it is a habitat, we can say. Food and space, these are very important basic resources for the organisms, are essential for the unimpeded population growth. Unimpeded is nothing but there is no disturbance. Okay, without any disturbance there is a population growth if the resources and space are available. Okay, they should be in limit, they should be in a level. Okay, because of that there is no destruction in the population growth, there is no problem in the population growth. Okay, if the food is available properly, then there is no problem in the growth of the population. If there is a space or habitat for their life, so there is also nothing is going to be happen for the population. Okay, and here next, if resources are unlimited. Okay, if the resources are unlimited, there is no limit for the resource. Okay, each species shows its full innate potential to grow in number. If the nature is going to be provide n number of resource or unlimited resources, it's going to be provide. For example, for dogs or for the tiger, if the tiger in a forest, tigers are there, and more number of deers are there, there is no scarcity for the deers, and number of deers are there. So the tiger can easily feed on the those deers, and they can reproduce exponentially, and the population also goes on increasing exponentially. Okay, it means the natural resource, if the natural resources are unlimited, the organisms can grow exponentially. Okay, or they can increase in it potentially. Okay, they are going to be grow in number by utilizing their inner potential. They are going to be feed on those resources, and then it will reproduce, and then it will increase in their number. Okay, increase in their number if those resources are proper, or n number or unlimited resources are present. If it is not possible for practically, but when the nature provide unlimited resources, the organisms or the individuals, they can grow exponentially. Okay, exponentially. And then the population grows in an exponential or geometric fashion. They are going to be grow exponentially. Say for example, you can take the bacteria, exponential growth of paramecium. Here they given the paramecium culture. For you are providing a good number of that nutrient to that particular paramecium. Here it is a single paramecium. Let's change the color. Okay, here the single paramecium is there, and we are providing all the food resource, whatever the paramecium need, that we are providing here. In a 0 day, what will happen? And in a 1 day, it is 1 become 2, and in the day 2 it becomes 4, day 3 it becomes 8, and it's 16, 32, and then it becomes 64, and then more than that 128, like that it goes on increasing. You can take paramecium and then bacteria also. If you are providing good resources or that nutrient to that particular colony for the bacteria or the paramecium, what will happen? They will increase in their number exponentially, because there is no scarcity in the food. There is only the target is feeding on the food, and then they can reproduce. Okay, like that happen in case of all the organisms. You can take elephants. If their lifespan is more, but apart from that also they can produce exponentially. Okay, that is the thing. And here they given population size and everything. Here they given before that. Here students, along with that, here you can take the bacteria we are calculating in 2 raised to n. We are calculating their reproduction 2 raised to n, because 2 to the power they are going to be multiply. 2 to the power they are going to be multiply. For example, you can take in a single the colony there is culture, there is a one bacteria, and 2 raised to 1 equal to it's 2, and then next in the second what will happen? 2 raised to 2 it becomes 4, and in third 2 raised to 3 it becomes 8, and then 2 raised to 4 it becomes 16, and 2 raised to 5 it becomes 32, and then 32 to 64, 64 to 128. Okay, and from 110 or 28 to next further it is going to be divided like that. If you provide the proper nutrient or proper resources, okay, the bacteria can grow exponentially. Okay, you can take the time in any way. For bacteria you are taking time in hours. Okay, if you take the another organisms for any humans and everything, you can take it as a years or months. We can calculate like that. Okay, it depends. And students, here the next thing, that is in exponential. Here the next slide you can see, if population size that is denoted by n. Okay, denoted by n. Population size we are going to be denoted by n. Birth rate we are going to be denoted by small b. Death rate we are going to be denoted by small d. Okay, small d. And then the increase or decrease in n during a unit time period. Okay, increase or decrease, okay, in the population density or the population size per unit time, we are going to be denoted by t. Okay, that t we can normally write here dn divided by dt. Okay, increase or decrease in the number or population size, okay, with respect to unit time, that is t. Okay, that we will write in dn divided by dt. Okay, dn divided by dt, like that we are going to be right here. Okay, and if you write b minus d, okay, and that formula we are going to be right here, sorry, formula we are going to be right here, dn divided by dt is equal to b minus d into n. Okay, b minus d into n, it is a birth rate, it is a death rate, and into n the number of population or the population size. Okay, and here you can see if b minus d, if you write r, okay, we'll take b minus d is equal to r, then we can write the formula dn divided by dt is equal to r into n. R into n, this is the formula what we are writing. Okay, r into n, for what purpose? If there is a change in the or increase or decrease in the population size with respect to time, we are going to be calculate with the help of this formula, that is dn divided by dt is equals to r into n. Okay, this is the formula what we are writing for population size calculation. Okay, this is the thing. This graph and everything we'll discuss later, it will come next. Next here, the R, what the R indicates here, what the R indicates. R is a intrinsic rate of a of natural increase. Okay, it's the intrinsic rate of natural increase. It means the capacity, the internal capacity of an organism. Okay, that is R. Okay, intrinsic rate of natural increase. Okay, how the naturally they are going to be increased, that is the R, is an important parameter for assessing impact of any biotic or abiotic factors on population growth. Okay, this is a very important pattern parameter that what we are using to calculate the population size. Okay, how the what how much it is increased and everything, how the abiotic and biotic factors are doing their impact on that in those organisms and on that population, that we can calculate. And here for the study purpose, for the convenient study purpose, they given one example here. A Norway rat, they given here the Norway rat, the R value, it means the size of the or the change, that is R value we can say here, that is intrinsic rate of natural increase, that is the intrinsic rate of natural increase, that is the value of R here they given 0.015. And another one example they given here, the floor beetle, that is 0.12. It is 0.12. It is increased here, it is increased more here. Okay, and then R value for human population in India in 1981, it is about 0.0205. Okay, these are the increase intrinsic rate of natural increase. Okay, how much percentage it is increased. Okay, that value we are going to be calculate here. Okay, that is the R value. Okay, that is the R value with respect to time. With respect to time we are going to be calculate the the Norway rat they given here, the floor beetle they given here, and then human population in India in 1981 they mainly given here. Okay, that is the thing. And next here, the integral form of exponential growth equation. Okay, here we are going to be write the integral form of exponential growth equation. You can write here nt equal to n naught into e raised to rt. It is e raised to rt, not ert, it is e raised to rt. Okay, e raised to rt it is. And nt, what they indicate here, nt population density after time t, number of and n naught here, population density at time 0. What is the population density at time 0? And r is here the same, intrinsic rate of natural increase, and e is the base of natural logarithms, the base of natural logarithm. I think you are familiar with in mathematics and physics, you are familiar with these logarithms and everything. Okay, and here the e indicates the base of natural logarithms. Okay, that is 2.71828 is the value of that e. Okay, logarithmic value of that e. Okay, this is the formula what we are getting here, that is nt is equal to n naught e raised to rt. Okay, e raised to rt, this is the formula. Okay, this is the formula what we are getting here. And coming to the graph, okay, just it's very important to observe the graph here. Coming to the graph, here you can see population growth curve. This is the population growth curve, we can see. Wait, okay, this is the population growth curve, and we are going to be plot it with respect to population density here, the population density, and then with respect to time. Okay, population density with respect to time we are going to calculate here. This I will draw in the next slide. Wait. Okay, here uh, this is the graph what we are seeing here. This is the graph representation. This is the x-axis, this is the y-axis, and here in this particularly for exponential growth, for everything, for logistic and exponential, here you can say the population density. You can take population density here. Here you can take the time. Okay, we can take the time here. And what happens, students, here in case of this, here the during exponential growth, what happens, the nature is going to be provide unlimited resource. Nature is going to be provide unlimited resource for the organisms. Nature is providing unlimited resources for the organisms. So what will happen, in the beginning there is a few organisms are there, and they will feed on the they are mainly depend on the sources of the environment, and they start adapting to that particular sources, and they start to increase in their number exponentially for exponential purpose, because sources are unlimited here. There is no limit for the source. So it is growing continuously. The number also goes on increasing here. Okay, number is also goes on increasing here, because there is no limited source for that. So unlimited sources are there, so it start to increase exponentially. Okay, here for example you can take here 4 individuals are there. Okay, population density, and the time taken here, the 10 years. I'm taking here 10 years, and in 10 years they are less in number. And coming to 8 population, there is also time taken, a lot of time taken. For example, you can take 20 years, and or you can take 20 months. This is the 10 month and this is the 20 month. And when they are adapted to that particular environment, when it is 10, they are 10 in number. Okay, they taken very less time. When not 10 here, 16 there, and after that 16, 32. When they become 32, they taken very less time here. When they become 64, they taken very less time here. Okay, time is very less, but they are growing exponentially. Okay, they are going very rapidly, and they are growing very exponentially. Okay, when it will apply, when the resources are unlimited at that time. So we can find a J-shaped curve. If you observe the curve here, it is like this. It looks like a J. So this we commonly call it as a J-shaped curve. Okay, it is a J-shaped curve. And even Darwin also. Okay, even Darwin also explained about this unlimited resources. If nature provide unlimited resources to the organisms, so they can grow exponentially, they can reproduce exponentially. It means the nature, if there is no act on the natural, there is no effect of the nature on the individual, or the nature is going to be provide unlimited resources. So at that time what will happen, there is an increase, or the rapid increase in the number of individuals, or they are going to be grow exponentially. The same thing was also explained by the Darwin. Okay, the same thing also explained by the Darwin. And here this is the J-shaped curve what we find here, and the formula we are using to calculate, that is dn divided by dt is equal to r into n. R is a, here R we can denote it as a intrinsic rate of natural increase. Okay, intrinsic rate of natural increase we can say here. And for uh, exponential growth equation, okay, what we are writing here for exponential growth equation is different. Exponential growth equation is that is sorry, that is here n t is equal to n naught e raised to rt. Okay, e raised to rt, this is different. This is the formula for exponential growth. Okay, this is the formula for exponential growth. So remember these two formulas important. These two formulas are important, so please remember. Okay, please remember that one important. These two are very important. Okay, this is the, if there is an increase or decrease in the uh, n or population density, we are going to be calculate with the help of this formula. And this is for exponential growth, that is nt is equal to n naught into e raised to rt. This is important, please remember. Okay, please remember what are the terms they are going to be give. nt is the population density after time t, and n naught is the population density at time 0, and r is the intrinsic rate of natural increase, and e is the base of natural logarithms. Okay, so please remember all these equations. Okay, and students, only the basic thing of this entire concept is, if the nature provides unlimited resources to the organisms, okay, they can grow exponentially. Okay, they can grow exponentially. You can take any organisms including microorganisms up to the large organisms. If they are getting natural resource or unlimited resource in the nature, if they are getting unlimited resource in the nature, they can reproduce exponentially, and then they can grow exponentially. Okay, this is the entire concept of this population growth, that is exponential growth. Here the natural resources are not limited, they are unlimited. Practically it is not possible, but in theoretically you can calculate, okay, the rate, change in the rate, okay, that we can calculate. So practically it is not possible. This is the thing about the exponential growth. Okay, this is the thing about the exponential growth. And students, uh, in the next class, okay, in the next class we'll study about logarithmic, that is a logistic growth. Okay, logistic growth we'll study in the next class. But students, I think all of you understood about this. Here this is the important, that is uh, the integral form of exponential growth equation. This is important, please remember. And along with that, the density, okay, the calculation of the population density, that is dn divided by dt is equal to r into n. This is also important, please remember. Okay, very simple concept is there. Just whatever the points there in your ncrt, those only I was explained, and go through that, and then you can get easily, you can understand the concept very easily. Okay, and in the next video lecture, students, will study about the logistic growth. That is also very important, that will study in the next class. Okay, thank you.